Hello friends, welcome to the talk, simulating and troubleshooting the thread leak in Kotlin application, right? So in this talk, we are going to be discussing about what is the way to simulate a thread leak in the Kotlin application and how we can go about troubleshooting it, right? That's what we're going to be discussing here. So for our discussion, here I have put together an hypothetical sample Kotlin program, so which will simulate a thread leak. So let's look at what's going on here. So here there is this class called as a thread leak app. It has this start function, which is the entry point to the Kotlin program. So when it comes here, if you see what's going on here, there's this while true. That means there is an infinite while loop going on. And within this infinite while loop, what it's doing is it is creating a forever thread. So we're creating a thread called forever, and then we are invoking it. We are launching the thread start method. So this is the source code of the forever thread, right? This is a forever thread. And if you see the run method, which is the method which gets triggered when the thread is launched, right? If you see this method as a while true loop, right? And here, if you see while true means it's also going on infinite loop. But within this loop, what it's doing is it is sleeping for 100 milliseconds. If a thread is launched, it's going to sleep for 100 milliseconds. It's going to wake up, and now it comes back on the next iteration because the while is true. Once again, it's going to sleep for 100 milliseconds. And then the next iteration, when it wakes up after 100 milliseconds, once again, it's going to sleep for 100 milliseconds. So that means typically this thread is going to be sleeping infinitely. That's what it's going to do. At the same time, if you see this thread is going on a loop, but whereas this in the start function, this start function is keep on manufacturing new threads. It keeps on manufacturing new threads and it's putting to sleep. So that means what's going to happen? Your application is going to be bloated with a lot of forever threads, which is keep on sleeping. So that means what's happening? A thread is starting to leak. A thread is starting to build up. And when it starts to build up, your application will fail. It will crash with the error. Java.lang.OutOfMemoryError, unable to create new native thread. Right? This is the error with which it's going to crash. This is what will happen when you execute this program. So when we launch this, when you run this program, how we are going to go about troubleshooting it, right? So you can, the best way to troubleshoot these kind of thread-related problems is you want to capture a thread dump, and then you want to analyze what's going on in the thread, right? So the thread dump is it's not very trivial. It is kind of a very tedious file with, especially these kind of thread dumps will be very large in size, right? So here is one automated approach, what you can look at using when this kind of problem happens, right? So there is this open source script called as yCrash, right? So what is this yCrash script? When it's triggered, this yCrash script captures 360-degree data, right? It captures like a 360-degree data, like it captures 16 different artifacts from your application stack. It captures garbage collection log, thread temp, top, dmessage, iostat, kernel parameter, like this. It captures 16 different artifacts. And then it creates a bundle, and which you can take and you can analyze. But also there is this also yCrash dashboard, the yCrash server, for which you can upload this bundle file, which has been captured by the script, and you can do the analysis, right? So let's look at the yCrash, the data which has been captured, and then when it's analyzed. So this is how that yCrash report looks like. So here is all those artifacts which has been analyzed. You can see it on the left panel. And here, this is a threads section. Here it is showing, it is indicating, right? It is having like 2,320 threads, which is there. In that almost 2,300 threads on kind of a waiting state. Right? They're not doing anything. So here the tool is highlighting. See, look at this. Here there's a section called as threads with identical stack trace. So the yCrash, it groups the threads which has the identical stack traces and present their count. So just one type of stack trace, that same stack trace is executed by 2,300 threads. And this is that stack trace. You can see it's visible. Here you can see that it is this thread leak app, which has launched as forever thread. It got launched and then it was sleeping. right? So this is basically a stack trace of this program. What is basically they're getting launched and they're not doing anything. So it is here in this time waiting state. The sleep means it's going to put your thread in a time waiting state. So 2,300 such threads have been created. See, when this thing happens, the tool clearly gives a warning. This is a 2i of account, and it's going to have this java.lang.OutOfMemoryError, unable to create new native thread, right? So using this kind of an approach, you can troubleshoot the thread leaks in the Kotlin applications, right? Any questions, yeah, on this? Okay, so I assume there's no questions. So okay, thank you guys. I will see you in yet another interesting topic. Bye.